Hey everybody, welcome. This is Introduction to Economics, video 4 of 4 for day 1. It's our last one, and it's going to be our toughest, guys. This one's going to be on marginal analysis. I might be biting a little bit more than we can chew. What I mean by that, guys, is after you get done watching this video, I can't promise you're going to fully get it. In fact, if you watch it twice, which might not be a bad idea, you still might not fully get it. But I can say this. When you get to the end of this program, this summer program, if you go back and watch this video, I guarantee you will fully understand it. So let's get into it. Marginal analysis, what's it all about? It's our way of making optimal decisions. Remember, economics is about decision making, and we want to make optimal decisions, and the key tool to do that is to do marginal analysis. You see, to make an optimal decision, we need to know how much of something to do. How many goods should we produce? How many workers should we hire? How many bites of food should you have at dinner? How many kids should you have? Or here's one that hits close to home. How many classes should you take in the fall? How many classes should you take in the spring? To make those decisions, we need to do marginal analysis. What we need to do is we need to look at individual units, and we need to say, hey, what is the additional benefit of doing one more, and what is the additional cost of doing one more? And guys, those are the definitions of marginal benefit and marginal cost. Marginal benefit is just looking at the additional benefit associated with doing one more. Marginal cost, the additional cost associated with doing one more of something. So here's where we're going to get a little bit mathematical, okay? I've got good A right here. Don't worry about this graph. We'll deal with that in just a second. But I've got good A and good A, two graphs for it. This first graph is my total benefit graph. This one is my marginal benefit graph. I want to say a couple things right off the bat. Number one, guys, I'm not drawing to scale. I'm just being conceptual. And number two, guys, I am monetizing benefits. So I've somehow figured out a way to put a monetary value to the benefit of this thing, okay? So when you see that dollar sign, I want you to think of benefits. And here's another thing. If you see this total benefit curve, notice all I have is dollars. So the only thing I've got here is benefits, right? When we do the marginal benefit curve for good A, remember this is good A and this is good A, the marginal benefit curve, I've got dollars per unit, which means benefit per unit. So here's the idea, guys. Good A is a very typical good. It follows the law of what we call the law of diminishing marginal utility. And let me just rephrase that. We can just think of that as the law of diminishing marginal benefit, which is this, guys. As we get more and more and more of something, the additional benefit is going to diminish. It's going to become less. That's why for this total benefit curve, guys, this curve is going to flatten out. You see, as we start getting this good, it's quite steep. The additional benefits are quite large, and that's why it's quite steep. But way out here, as we're getting more and more and more here, guys, it's flattening quite a bit. The additional benefits are less and less. Again, the law of diminishing marginal benefits. So, when we graph the marginal benefit, the curve is going to be downward sloping. Remember, what's marginal benefit? It's the additional benefit for one more. Now, remember, all of these are going to be units. Now, I'm saying these. Let me get a little bit micro with this graph right here. This point right here is associated, we're going to say, with the first unit, okay? So for the second unit, the benefits are still going to be positive. They're just going to be less, right? Here's the benefits we got from the first one. Here's the additional benefits associated just with the second, and it's less. They have diminished, right? This should make sense for us. As we get more and more of the same good, the additional benefit becomes less and less, and that's why this marginal benefit curve is downward sloping, and it's why this total benefit curve has this type of look where it's flattening as we're getting more and more right here. Okay. Now I'm going to change, okay? I'm moving off of these two graphs, I'm going to move to these two graphs. So what I'm about to do is stylize the world. I'm going to say that we have a world in which we can only make two goods, good A or good B. And, of course, therefore, when we make good B, we're giving up good A, and when we make good A, we're giving up good B. But those are the only two goods we can make. Now, with that said, let's say with our lump of resources, and let's just say here's our lump of resources, okay, that we have. With our lump of resources, if we allocated all of these resources to good A, we could produce where that red arrow is. We could produce that much of good A, which would mean we would produce 0 of good B, right? These resources is all we have to produce either this or this. Maybe it would have been better if I had drawn that right here, okay, so that you know that these resources can be used to either make this or this good, all right? So with that said, again, if all we do is produce good A, we could produce all the way to here, but that would mean 0 of good B. So what I want to do is I want to put our marginal cost curves on these graphs. So imagine this. Let's imagine that instead of producing only good A, we decide, hey, let's produce 1 unit of good B. And guys, I'm basically going to assume that the resources needed to make 1 of good A is the same amount of resources to make good B. Another way I'm stylizing this just to get the concept. So again, instead of making only good A, we're going to say, hey, let's make 1 unit of good B. What is the cost, okay? What is the cost of making 1 unit of good B? So I'm going to go be able to put my marginal cost, or at least the beginning of my marginal cost curve on this graph as I think about this. So instead of making all of good A, we're going to make 1 unit of good B. What is the cost of that? Well, hey, opportunity cost, right? We're going to forego that amount of benefit, right? We're not going to be able to make that last unit anymore. So we're going to forego that marginal benefit. So guys, that is our first dot on our marginal cost curve for good B. Now let's say, hey, let's make another unit of good B. To make another unit of good B, we're going to have to forego another unit of good A. So we're going to have to forego this one also, right there. So the cost of making the second unit of good B is that much. That's what we're foregoing. That's our opportunity cost. So let's go ahead and put a dot right there. Now let's just do that one more time to make sure we've got it. Let's go ahead and say, hey, let's make a third unit of good B. What is the cost? Well, it's the marginal benefit foregone. The marginal cost, the additional cost, is the additional benefits foregone. To make that third unit, we're going to have to give up this unit right there, that unit of good A, which has this many benefits, or that amount of benefits associated with it. So I'm going to go ahead and put my dot right there, and now I am able, let's just go ahead and draw in the marginal cost curve for good B. See if I can get that in here really quickly. So marginal cost curve of good B. Not the best ever, but there we go. I'm going to put a little knot. We'll get back to that. Now, if you didn't fully get that, we're going to do it again. We're going to do it from the opposite perspective. Imagine we took all these resources and we just made good B. If we did that, well, we could produce all the way to that red arrow, right? But let's say, you know what? We don't want to do that. Let's go ahead and make the first unit of good A. So what is the cost? I'm going to go ahead and get rid of that right here and that vertical right there. What's the cost of making the first unit of good A? Well, the cost of making the first unit of good A is foregoing that amount of benefit right there, right? That last unit of good B. I'm going to go ahead and just kind of eyeball it now. Put a little dot right there. That vertical is the marginal cost of making the first of good A. And guys, that vertical is associated with that vertical. That's what we're foregoing, right? Now let's do that again to make sure we've got it. Let's say, hey, let's make another unit of good A. Let's make one more unit of good A. What's the cost? Well, now we're going to have to forego another unit, right? I'm backing up from here. We're going to have to forego another unit of good B. That might put us about right there. So let's go ahead and connect these dots and get our marginal cost curve, right? This is our marginal cost curve. So it's not going to be the prettiest, but there we go. I intentionally made these two marginal benefit curves not symmetric, okay? I didn't have the same slope for both marginal benefit curves. They're two different curves, so it makes sense that they can have two different marginal benefit curves associated with them. Now, with that said, how much of good A should we produce, and how much of good B should we produce? Well, for good A, how much should we produce? As long as the MB exceeds the MC, do it. Do that thing and stop when you get to this equality. That's where MB equals MC. So this right here, whatever that might be our third unit, right? That will be the optimum. Now, how much of good B should we produce? How much of good B should we produce? Well, we should do that as long as MB exceeds MC. Well, MB is exceeding MC for all of these goods. all the way to this point. At that point, MB equals MC. That's our optimum. That's how much we should produce. So now, here's where we get really mathematical. If I was to go ahead and say, all right, I'm going to take this right here, that line, and I'm going to draw that down right here, just like that. And then I'm going to take this slice right here, that slice right there. Oops, not great with the meter stick. And this slice right there. If I was to integrate that, okay, and integrate just means adding up slices to get to the total, right? If I was to integrate that, meaning adding up this slice, and this slice, getting my total benefits. And I was to do the same over here, okay? So there's my marginal benefit curve. I'm going to draw this line down right to there. And if I was to integrate this marginal benefit curve, all right, I'm going to integrate the marginal benefit curve. I know it's taken too much time. This is dead air on the video. Not the best thing to do. So let me try to rush it as fast as I can. But if I was to add up all of these slices, remember, when we integrate, we're adding up the individual slices to get to the whole. What I'm saying is this would give us our optimal result if we produced this amount of good A and this amount of good B. That is the best we can get. This area right here, this area right there that you're looking at, and this area right there that you're looking at, okay? Remember, integrating the MB, that's adding up the individual slices of the MB to get the TB, the total benefit. Those two areas is the maximum we could get out of this, out of these resources. If we produced one more of good A and we'd have to back up one more over there, I guarantee you we would get a result that was less than optimum. If we tried to produce one more of good B and backed up one on good A, we would get a total benefit which would be less. Our maximum amount of benefit we can get from these resources is going to be based on what we just did, on producing until those intersection points of MBMC, producing to right there and right there. That gets us our optimal. Again, I knew this was going to be a hard video. I know it's pretty mathematical, but guys, this is just an introduction to marginal analysis. The idea that, guys, we're going to go break things up into individual units, and we're going to do things as long as the additional benefit exceeds the additional cost. And we're going to stop once we get to an equality, and that equality represents our optimum, our maximum, our best result. Anyhow, hope that made some sense to you. We'll see you in the Zoom session.